Hello everybody, welcome back to my channel, to my vlog, and on the bench today we have one of these. This is the L12-2 Amplifier, and my one's all built up. I've been listening to this and using this for a while now, and I think it's very nice. I'm just going to get a bit closer there. I think it sounds very nice. Definitely on the square wave, that does have advantages over some of the other amplifiers built, and this particular one is, I would say, it's probably my favourite. There's another contender, and that's in my bedroom. I do really like listening to it in there, but just for now we're just going to take a quick peek at this over here on the screen. And as you can see, this is an LJM circuit, the L12-2 power amplifier. It doesn't claim to be a copy of anything or anything like that. This is it says here that this is the circuit. I'm not sure if it is, just because, well, we've got two lots of output transistors here. These are Darlingtons. Just because it says that LJM doesn't normally give the circuits with theirs, so I don't know. We're going to take a peek down at the specs. So I was just going to say here, actually, this is mono with a radiator, and that's what you'd have. You'd buy two of these if you were going to buy like that. So it's a little bit pricey compared to some of the other amplifier circuits. That's the mono subwoofer. I don't know why that's a different price. Maybe it's because the quiescent current is higher on there. I'm not sure. Mono with radiator. It doesn't say that one has a radiator, but I don't know why it'd be any different. And then you get the two. You can get the two-channel kit for two of them, £25, and then you got to buy your own radiators, heat sinks, or you can get them pre-built. But you got to get your own heat sinks, or you can get a mono with a heat sink. And I would suggest, get the heat sinks. So you bring your own welding tools. The L12-2 power amplifier rear stage kit, high performance amplifier designed by LJM, is strictly tested. We've got an ultra low distortion amplifier. So look, voice tends to be colder and harder, requires attention. I'm not sure what some of this is about. This is what I do like to see. The supply voltage is within plus minus 55. Circuit diagrams are not provided for all LJM models. Do not buy if you mind. Okay. Parameters: power 120 watts into the 8 ohms, plus minus 50 volts. 200 watts 4 ohms, plus minus 50 volts. THD, not THD and noise, THD 1 kilohertz at 10 watts is 0.000, I like that extra zero in there, 5. This is a slew rate. Why are they doing that? No, the damping factor, they don't normally, none of the other amplifiers I've noticed a damping factor there, but that's pretty good. Input sensitivity equals 1.6 volts, output is 120 watts at 8 ohms. 15 hertz to 50 kilohertz, minus 3 dB. Not sure if it's telling us we're going to get minus 3 dB, or there's a not quite sure about that. 20 hertz, 20 kilohertz, there you go, that's better. 0.02 dB, quiescent current 80 milliamps. Alright, well, this is one of the things on these, and I expect that's going to be at the full volume. Voltage range equals DC positive, negative, double voltage, plus minus 12 volts to plus minus 55 volts. Voltage amplification factor is 31 times. Alright, input signal. Oh, for the THD noise test. So look, that's how he's got his setup here. And take a peek here. So for this is our THD plus versus frequency. But this isn't the frequency down the bottom, but this looks like it's a THD type thing. And you can see in its best place down here is 0.05, yeah. And if we just go across here, this is a nice flat. It's obviously got a little bit of going off down here, a little tiny bit down here. And this is versus frequency. So we can see that our lowest is from sort of 13k here. But never mind, that's all good. Very easy to build as well. And if you get the radiator, the heat sinks with it, what you'd do is you'd just put these onto the heatsink and then bend the legs of these transistors appropriately, and then this you get just to sit on top of there and solder it on, so it acts as its own. If you had standoffs in, you don't have to do it like that. I did it like that and it seems to be perfectly okay. Here they got like a little ceramic thing there, but there's a film one on mine. Yeah, I can't see any other differences really, apart from here as well. I've got a mine's a bipolar, and there's a bipolar there as well. So electrolytics on mine, let me just show you. I don't know if it's, you see that film one here rather than the other one, and there's a bipolar and there's a bipolar there on my one. It's going to be different, I expect. Well, I mean, I don't know. Your kit can come through different, I'm not sure. But let's have a look and see what it does. Let me just get rid of that. Now, we are running at the moment on 12 volts, because it said 12 volts. That quiescent current, of course, is not 80 milliamp, that's 14 milliamp. But we're not going to worry about that too much, because if we were running at the 80, the full power, we could be close to 80 milliamp, I'm not sure. We'll see in a moment anyway. So let's run this, and at the moment we're running at minus 17 dBFS. We've got a really nice low. This would be the total harmonic distortion it talked about. Now what I'm going to do is, at the minute we're using around about half an amp. I just keep that, come here. I just keep that there for a minute. Alright, so we've got about half an amp there. And as I start turning up on this, don't worry about what the number says here, because that's just in relation to my output, the feed I can put into the amplifier. Nothing to do with the amp really. So as we start going up, you can see that the current is going up. But you can also see that we've got this little 3K. There's a little 3K bit here. Let's just get as close to 3K as we can. There we go. And now the THD look is on its specification there at minus 12 dBFS. And if I were to take this all the way up to its minus 3, we're going to see some distortion. I'm pretty sure we're going to. Wow. All right. Let me just back that off to 3. So there we go. Let's just take the pressure off the system a bit. Really using that's at 12 volts. Oh, let me put that back on again. At 12 volts, look, we're using 0.628. You know, somewhere between that and the 0.622. And that's very good, because our 3K is minus 115.4 dB down. Our total harmonic distortion is within their spec, which they said it was 0.0005, and it is. Very good as well, because it's 1's the next digit. Total harmonic distortion and noise, 0.001, very good. And it's just nice to see that there's hardly anything, is there, on there. I mean, it's all way below the 100, a lot closer to the 120 dB than what it is the 100. So let's have a look. 951. Yep, that's on the second harmonic there, coming off our fundamental. We're at minus 114.91. I think this is all inaudible. Inaudible, and that's running at 12 volts. All right, that's running at 12 volts, and that's done absolutely very well indeed. That's splendid. All right, so now I'm just going to turn up the voltage in there. I'm going to turn down the power here in case I forget. And we're going to turn up the voltage. So let me just make sure I'm on the right one. And we're going to put it to 24 now in case you're in a truck. say 25, because that would be good enough. And as you can see, look, the quiescent current goes up a little bit. And so we can see the noise floors drop there. Just start turning this up. We're back at that 17 dB, which we had a look at before. We can see that we're using 0.46 of an amp, and we're down at 0.0002. It's nice for the total harmonic distortion. We can't see anything of the harmonics yet coming off this fundamental. Not a thing. Let's turn that up and get it close to 3 dB. Alright, here we go, beautiful. Alright, so now we're using 1.2 amps, nearly 1.3, and our total harmonic distortion and noise at the -3 dB. I'm just going to take the pressure off the system. Is 0.0005. 6, which is still within their spec, and this is, you know, this is fantastic. It's absolutely lovely. Let's have a look at the highest peak that we got is the 3 kilohertz. Let's just take that up to 3. Oh, 3 kilohertz, and we're down at minus 111.53 dB, which is, you know, brilliant, absolutely brilliant. Our second harmonic, just for the sake of having a peek at it, why not? There, minus 115. So again, you know, that specification is bang on. It's brilliant. It's yeah, very good. All right, well, I can't take it any higher than 32 volts with this setup, doing it like this, and I just wanted to do all of them like this, just to keep it, you know, sort of fair, I suppose, when looking at them, if you're going to look at them over these ranges. So I'm just going to turn this down a little bit and just put that on again, and we'll see what that comes in at. Look at that nice low noise floor low. Look at that. I mean, that's probably about as low as what I can measure. I want to go up there, so we go back to that 17, just have a little look, try and keep it all within the same. Oh, can't see, there we go. And we're at 0.00023, again 0.0024. Lovely, and we're using half an amp again. We'll go up to, I think it's around about there, and that puts us there, and that's on our 32 volts going in the side. I'm just going to take the pressure off. And again, I mean, it's early, I think we've gone down 1 dB, or gone up, I should say, because we're on a minus 1 dB, so we're at 115, aren't we? Now we're at 114. But the difference on that is I'm going to make it less than that. But again, the THD and the noise is 0.001. Brilliant. I think that's better than before, a bit higher voltage. And the THD by itself 0.00056. Fantastic. Cannot complain at that at all. And I think we've lost a few dB from here on the 3 kilohertz, so you know, that's got a, but again, it's just nothing to even consider. And the quiescent current there using 31 volts or 32 volts is 28 milliamps, let's say. Brilliant. We're doing just a quick frequency response at this voltage, just making no difference. Just put that on, hit the frequency response. Boom, there we go. And this is our line across here. Let's try and just fit that in a bit. Move that down to about there. That'll do. I mean, that's putting us on 0.5. If we're going to see anything, we're going to see anything here, and there's nothing really. Is that's 20 kilohertz. I think we can just bring that over. One more for that. Boom, boom. There we go. And that we can fit that in to a 5. See, there's the 10, and it does say, I think it's from 10, doesn't it? That 0.5. So really, it's still it's 0.46 there at 7.2, and at 20, we're just under 0.04. So again, well within the range of its specs. Lovely, absolutely lovely. Oh, that's it for that, guys. That's all we need to do with that, really. And that lovely amplifier. And it does sound really nice. That's all I can tell you. It's in actual fact, for the majority of people, let's just have a look at it. It's my speakers in my bedroom go down to 46 hertz, so it's a flat line pretty much. 45.41, and it's there's nothing there. It's near enough a flat line all the way to for there. And my speakers in the lounge here go down to 35 hertz, which will be here, and again it's a flat line. So even if it drops off here, if you've got speakers that go down to 15 hertz and you're just dropping off 0.02 dB, it's nothing. It's nothing. It's yeah, very good. I do like this amplifier, I must admit. It is very good. I do like the idea that it's two separate. I do have another amplifier, and even though I think that sounds very nice, it's the one that I got in my bedroom connected to my acoustic Q-Acoustic 3030Is, and that does sound really nice. But the thing that I like about this one the most is it's two separate amplifiers, which means you can have two separate power supplies going to it and have proper mono blocks, and I always prefer that. It's yeah. So yeah, if you were going to ask, is that good enough to buy? Is it something that you'd want to use and keep? I'd say to you, yes, absolutely yes. Thanks for watching if you got this far, and I will catch you in the next one, guys. Bye bye for now.